All right, boys and girls, let's go ahead and look at lesson 8.1. Since this one is so long, I'm going to do something similar to the last one. I've picked out certain problems that will kind of be representative of what you're going to see on these ones. So I will actually be solving problems that are on your guys' worksheet. So if you follow along with me, you'll be able to get some free answers, basically, and it'll definitely help you with some of those future ones. Okay, so in this section, this is where we're solving systems of linear equations by graphing. And some of the other videos have already kind of touched on this a little bit. But this one's more just kind of the nuts and bolts, just practice. Okay, so this one's going to be a little more direct, a little more concrete, but it is pretty long. So we're going to go through as many of the kind of representative ones as I can. And as we're going to start kind of slow, as we go through some of the later ones, we might speed up a little bit just to kind of not rehash the same thing over and over again. So feel free to stop, rewind, back the video up, and if you have any questions, feel free to contact us using the means you guys know, Microsoft Teams or email or through our Google Voice numbers, okay? All right, so let's take a look at problem number 1. So I'm actually going to skip for just a sec. We'll come back to it. I'm going to skip this first one. It's a little bit different. It's kind of odd compared to the other ones. But this second one is basically in perfect slope-intercept form. Okay. So one thing we're going to need throughout this page, and you want to make sure you remember this, and we've talked about this a little bit in every other video, but just going to mention it again: y equals mx plus b. So remember that m is the slope in this case. And that's the thing that's attached to the x variable, okay? That's the coefficient of the x variable, the number next to it, or in some cases a fraction next to it, okay? And then b, remember, is the y-intercept. So in other words, where the graph crosses the y-axis, okay? And when I'm graphing in slope-intercept form, I'm always going to start with the y-intercept, okay? So for this problem, okay, again, we're looking at the second equation here because that one's in perfect slope-intercept form. Well, if you look at it in y equals mx plus b terms, well, my m is the 2, and the b is this -7 right here, okay? So let's go ahead and take those numbers and turn them into things that are usable, okay? So the first thing we're going to do is we are going to plot the y-intercept. So again, remember, I'm going to find the y-axis, and then I'm going to find -7 on the y-axis. Okay, so I'm going to zoom in a little bit to make it a little bit easier to see. Okay, so I plot my first point on the y-axis at -7. So I'm counting by ones in this case and go down to 7. Okay, so I plotted my first point. So you always will start with the y-intercept. Okay, after that, though, then that's when I use my slope. And remember, we've talked about this in a few of the videos. Slope is rise over run. So I want to make sure that I make my slope into a fraction if it's not already 1. Now, some of the times it's already going to be a fraction, but sometimes it's a whole number, like this case, or an integer. And so we're going to put 2 over 1. Remember that any whole number or integer can be turned into a fraction. In fact, anything can be turned into a fraction if you just put it over 1, because when you divide by 1, it doesn't change the value of your number. Okay, so 2 is my rise, or my change in y, and 1 is my run, or my change in x. So I'm going to go from my y-intercept point, and I'm going to rise 2. So in this case, I'm going to rise up 2, and then I'm going to run 1 to the right. And then I'm going to rise 2, 1, 2, 1 to the right. Rise 1, 2, 1 to the right. And then you can kind of just repeat that process. I like to do it at as many points as possible just because it helps me draw a little bit straighter line. Technically, we only need 2 of these points, but it's just easier to connect and make your line pretty straight when you have more lines than that. And since we're going to be making multiple lines on this, we want to make sure our lines are as neat as possible, okay? Because most of the time, our solutions are actually going to happen on these kind of perfect points. That's kind of just how these problems tend to be. Now, technically, they could meet anywhere, but most of the time, the textbook pages tend to give us whole number answers, and that's kind of helpful to us. Okay, so let's go ahead and look at our next one. Now, this one, like I said, I saved it for last, or saved it for second in this one because it's a little bit odd. So if you look, it's kind of missing something, right? There's no x term here. Okay, so there's nothing that's attached to x. So effectively, we want to treat this equation like it is y equals 0x minus 1. Okay, so because there is no x part here, it's effectively like I have 0 x's in that case. So I'm going to treat 0 effectively as my slope. This is essentially going to be a slope of 0. Okay, so let's take our same logic and we're going to plot those points. So same idea as before, okay? The y-intercept is -1. So I'm going to go down to -1 and plot my first point. Okay, now it's kind of weird that my slope is 0, but I still treat it the same way. I'm still going to make it into a fraction. Let me get this y equals mx plus b out of the way. I'm going to make it into a fraction by putting it over 1, okay? And I'm going to rise 0. So that means I'm not going to go up at all. I'm going to stay exactly where I am, and then I'm going to run 1. And then I'm going to rise 0, and I'm going to run 1. And you can kind of see the pattern of what you're going to get here, okay? And a line with a slope of 0, we've talked about this before, that is a horizontal line, right? And it kind of makes sense if you think about the word slope, right? When we think about, if I describe a slope, I'm talking about like a hill or, you know, going skiing maybe, right, on a mountain, okay? If something has no slope, you would describe it as most likely flat, okay? And that's why a horizontal line, it's a good way of thinking about a horizontal line as a slope of 0 because it has no slope to it. It is not steep at all, okay? Now remember, the solution to these problems happens where the lines touch, okay? And that is at this point. Okay, I'm going to move my arrow actually because it's kind of blocking. Oops. Move my arrow because it's kind of blocking the point there. Let's try this one more time. There we go. Okay, and so now, remember the final step here is to give your answer as a coordinate, okay? As an x and a y together. Okay, so for this case, my x coordinate is going to be 1, 2, 3 to the right, so +3, and 1 down, so -1 in the y. Remember, it's always over to x and then down to y. Okay, so in this case, my answer should be 3, -1. Okay, so both of these problems were in slope-intercept form. Now, even though that first one didn't look like it was in slope-intercept form, it actually was. Once I realized that the slope was 0, and basically had 0 x's there, it was still basically in slope-intercept form. Okay, now these other ones that I've marked, we're going to do number 2 and number 3 on this page. Number 2, they are not in slope-intercept form. Remember that slope-intercept form is y equals mx plus b. So I need to have my y term alone and equal to +1y. Okay, so right now, neither of these problems are set up to solve. None of them have y isolated. Okay, so that's got to be my first process throughout all these. Now, thankfully, we know how to do this. Okay, we can get y alone. Okay, so every time you're looking at one of these, you want to be, before you can graph, you want to be asking yourself, is y alone? And if not, you need to be doing that first. You need to get y alone first. So let's take a look at our first one. X minus y equals 6. Well, if I'm looking at this problem, right now the only side of the problem I'm looking at is this left side of the problem. Okay? And I want to be looking at anything that is with the y that I don't want to be there. Okay? And because remember, at the end, all I want is just the y. So the first thing I'm going to do is I'm going to get rid of everything that's around y. So right now, that is this x here. Okay? So remember that if I want to make one x go away, well, the way I would do that is I would just subtract x. Okay? And then if I follow my rules of equations, if I subtract something on one side of a problem, I'm going to follow that by subtracting on the other side of the problem. Okay, so then my next step is just to write down what I have left. Okay, so on the left side, the x's went away, they became 0, and that left me with negative y. Okay, again, watch for those negatives. Don't forget to bring that negative down because that y is not a +1y yet. It's not totally alone yet. We have one more step to go. Okay, the right side of our problem. Now this one we want to be really careful on. Okay, remember, not like terms. You cannot subtract 6 and x. So we're just going to write this down as 6 minus x. Okay, so we're getting closer. Y is almost alone now. Okay, so now I need to get rid of this negative in front of it. Okay, and if you remember that any variable that's by itself or with no number in front of it, you can always write a 1 in front of it. Okay, so in this case, my y is effectively a -1y. And if I want to get rid of this -1, well, all I have to do is divide by -1. Okay, but remember the rules for multiplication and division when it comes to equations. I have to divide by -1 to every part of the equation. Okay, so 6 is going to get divided by -1, and negative x is going to get divided by -1. Okay, so that's going to leave me with positive 1y, because a negative divided by negative is a positive. Positive 6 divided by -1. A positive divided by a negative gives me a negative, so this is going to be -6. Okay, and in this case, a negative, because this is basically a -1, kind of like the same reason why negative y was -1y over here. -1 divided by -1, well, that comes out to positive 1. So that just means it's going to be plus x, or plus 1x if we want. Okay, so now I've got y alone, but not quite done yet, because it's not in the order that I want it, right? It's pretty common when students see stuff like this that they go, oh, this is the slope, and this is the y-intercept. But if you look, remember the slope, the m, this is the thing that's attached to the variable, attached to x. It's the coefficient of x, okay? So that means that in this case, my slope is actually this one right here, because this is the one that's attached to my variable, my x, okay? So what I'm going to do is I'm just going to take these, and I'm just going to flip them around, okay? And again, I'm going to make sure that I keep the signs. So this 6 is going to stay negative, and this 1 is going to stay positive. So when I move it around, I get y equals 1x minus 6. Okay, and once we've gotten it to this step, well, I just have to do the normal graphing like I did before. So I'm going to start with my y-intercept, go down to -6. Okay, and then I'm going to go up 1 and right 1, because my slope is 1 over 1. Okay, so I go up 1 and right 1, up 1 and right 1. And I'm just going to continue that for a few extra points, just so again, I technically only need 2 of them. It's going to help me get a straighter line. Going to help make sure I get my answer correct. Okay, so more points is better. Right, we have one more to do for this problem. So let's look at 2x. As my battery's running low. Well, give me just a second as I plug in my computer, because that would be a bummer. All right, momentary technical difficulties. We're going back to solving the second equation here, 2x equals 12 plus 2y. Okay, so from here, again, I want to be looking to get y alone. So this time I'm going to be looking at the right side of my equation, because that's where my y is right now. Okay, and if I want to get rid of everything that's with my y, okay, the first thing I'm going to do is I'm going to get rid of everything that's not attached to the y. So I'm going to, just like how before I saved the -1 for last, I'm going to save this +2 for last. Okay, so just like before, just like how I got rid of the x over here, this time I'm going to get rid of the 12. So I'm going to subtract by 12, and then I'm going to repeat that process on the left side. I'm going to subtract by 12 on the left. Okay, again, remember that because this has an x and this doesn't, this is going to be 2x minus 12, and then equals, well, on the right side of my equation, the 12 became 0. 12 minus 12 was 0, and so all I'm left with is +2y. So the way I'm going to write that is just put 2y. Okay, so the last step we have to do is we have to get rid of the 2 here. The way I'm going to do that is, again, divide by 2, and then again, following the same rules. You'll see there's a lot of overlap here, so even though this problem was set up differently, there's a lot of similarity, okay? So when I divide by 2, just like how I did with the -1 on this side, I got to divide everything by that 2, okay? So then let's work it from here. So 2x divided by 2, well, 2 divided by 2 is just 1, so it's going to be 1x. -12 divided by 2 is going to be -6, and this is going to be 1y, okay? And now if I just kind of rearrange the equation, put it in kind of that slope-intercept form we're used to, I'm going to put the y first. So y equals 1x minus 6, okay? And you'll notice something here, okay? Notice how these equations are the same. If I went through and I was to actually graph this, I would graph the exact same line, okay? So remember that if you end up with 2 lines that are completely the same, then that means this problem has infinite solutions, Okay, so I know this problem was pretty complicated, okay? But again, take it step by step. And remember, anytime you have an equation that is not in slope-intercept form, that doesn't have y isolated, and then mx plus b, okay, you need to adjust into that form. So use these as your model because these equations are going to be very, very similar to every other one you see on the page that's not already in slope-intercept form. Okay, and one last thing before we move on, remember that you do not need to do this process if they're already in slope-intercept form. If they're already set up for you, you don't need to rearrange them. Okay, so for example, when I look down at 3 and 4 here, okay, well, 3, all the equations for number 3, those are not in slope-intercept form. So I'm going to need to change them over. Okay, but for 4, notice how one of these is already in slope-intercept form. That equation you can just graph. The other one you will need to change into slope-intercept form. Okay? All right. Moving on to our next question. So I'm going to skip number 5. We are going to do some word problem ones. I'm going to kind of show you guys one of those with some of these with a harder one. Okay? Because I think this one is a little bit trickier to do. Okay? Because part of the problem that makes these a little bit more difficult when you do the word problems is these are systems of equations. That means there's going to be 2 equations from all of these different things. And some of them can be really tough to see. Okay, so let's go ahead and read through this problem. So it says Kelly needs to order lunch for orders 6 people. Need to order lunch for orders 6 people at a business meeting. Her menu choices are chicken salad for a cost of $5 per person and egg salad for a cost of $4 per person. She has only $28 to spend, and more people want chicken salad. Okay, so she's only got $28 to spend. Okay, so basically if we look at this, the equation that most students are going to do first is the cost equation. Okay, so the first equation we're going to deal with is going to deal with all the money. Okay, well, we know that total, she has $28, right? That's the maximum amount of money she can spend. So regardless of whether people order chicken salad or egg salad or whatever, she's going to spend $28. Okay, we also know that the chicken salad people are going to cost $5 per person. Okay, so that means if one person orders chicken salad, it's going to be $5. If 2 people order chicken salad, it's going to be $10, and so on and so forth. Okay, so I'm going to represent that as 5 times C. Okay, and C is going to represent the number of people who want chicken salad. Okay, and you can probably logically figure out what the next one's going to be, right? If $5 per person was the cost for chicken salad and we made that 5C, well, then we can probably make something similar for the egg salad people. Okay, we're going to do plus 4E because this time the egg salad costs $4 per person, and we're going to use E to represent. E is going to be the number of people with egg salad. Okay, so we've set up our first equation. 5C plus 4E equals 28. Okay, this next one is a little bit tougher. I think this is one that a lot of students struggle with. Okay, and it turns out the only number we need for this problem is actually in this very first sentence. Okay, she only orders for 6 people. Okay, so remember, C is the number of people who order chicken salad, and E is the number of people who order egg salad. So if you take those 2 numbers and you add them together, what does that equal? Well, everybody's getting lunch, right? And there's 6 people that she's ordering for. So that means if I take the number of chicken salad orders and add them to the number of egg salad orders, I should get the number 6. Okay, so in this case, it looks like this problem wants us to use x and y for our variables, and that's fine. We can totally do that, okay? Now, in this case, it didn't specify which one is which, so we actually get to choose, okay? So I'm just going to say, just because I like it a little more, I'm going to say that y is the chicken salad, okay? So we're going to treat c as our variable for y, okay? Now we're going to treat x as our egg salad people, as our E. Okay, so let's go ahead and say what x and y represent. So x is E or the egg salad people, and Y is going to be C or the chicken salad people. Okay, so before we can answer number 4, we need to go ahead and graph our equations, because actually I kind of skipped ahead on 1 and 2. We didn't graph those yet, so we want to make sure we do that now. Okay, and the problem is right now neither of these can be graphed. Okay, so we're going to treat, again, we're going to use C like it's our Y value and E like it's our X value. Okay, so I'm going to take the first equation here, 5C plus 4E equals 28. Okay, and again, remember, I'm using C as my Y. So this is going to be the thing that I want to isolate, that I want to get by itself. Okay, so what do I need to get rid of first? Well, I would get rid of this X, or in this case, the E part, and get it away from the C. So I'm going to take away 4E on the left side, and I'm going to take away 4E on the right side. And again, like we did before, I know that I can't subtract 28 and 4E. Okay, and on the left side of my problem, I'm left with just the 5C, right? Because the 4E's became 0. Okay, my last step here is to divide by 5 on both sides. Okay, and in this case, it leaves me with C equals, now if I take 28 over 5, I'm going to put it into the calculator just to make it easier for me to graph this. Okay, 28 over 5 comes out to 5.6 minus 4 over 5E. Now you might be asking yourself, why didn't I put that into the calculator to get its decimal version? Remember, this is going to end up being our slope, right? Because it's attached to our variable that we're using for x, in this case, the e. Okay, so we're okay if the slope is a fraction, right? In fact, we want it to be a fraction. So this is a good thing. Okay, so we're actually going to leave this one as a fraction to kind of simplify it for ourselves. Okay, and again, we're going to do a really good job to make sure, we're going to sketch this one. It's going to be kind of tough to get perfect on, but we can at least get a good idea of the answers here. So last step, again, I want to make sure I put it in the right order. So this negative 4/5 e should come first, because I want to make sure that my variable part comes first, and then plus 5.6. Okay, so now if I go ahead and graph this, I'm going to start by doing 5.6. Okay, well 5 is right here and 6 is there, so 5.6 is going to be a little in the middle, just a little above halfway of those two. I'm going to do my best here, and again, it's going to be tough to get perfect on this one. We're just going to do as best we can. Okay, so now from here I'm going to do my slope. So I go down 4. And again, I'm counting from the middle. So down 1, 2, 3, 4, and over 1, 2, 3, 4, 5. Looks like I'm going to be about right there. Okay, I'm going to go ahead and draw my line in. Okay, so that was our equation that represented the costs. Okay, well, we have one more equation we got to worry about, and that is the number 2. Okay, so I'm going to give myself a little more space here. Remember, that equation was C plus E equals 6. And again, just like last time, I'm solving for C in this case. And this one's going to be really easy to solve for. Okay, all I need to do is subtract my E on both sides. Okay, now C is already a positive 1c. I don't need to do anything else with that. Okay, but this right side of my equation, C minus E, all I have to do now is take that and flip it around. And again, remember, I'm going to make sure that the signs stay the same. Well, this E is a negative E. So that means when I move it around, C equals negative E plus 6. Okay, now I'm going to go ahead and plot this one. This one's going to be much easier to graph. This one, I'm going to change colors just because they are going to be pretty close together. So it's going to be tough to kind of graph this one by hand, but I'm going to show you anyway. Okay, so my first point is going to be at positive 6. Then I go down 1 and right 1, down 1, right 1, down 1, right 1, down 1, right 1. And man, this one is really, really tough to see exactly where my solution is. Okay, so sometimes that happens when you graph by hand, and that's why I kind of strongly recommended to you guys that you downloaded Desmos. Okay, so let's go ahead and take a look at our two equations. So our first equation, we got C equals negative 4/5 x, or sorry, I guess we did e, excuse me. Oh, it's not going to like e. I'm going to use x just for the sake of Desmos, because e is actually a number in math later on. And this one was 5.6, I believe, wasn't it? Yes, it was. Plus 5.6. The next one, c equals negative x plus 6. Oh, I'm zoomed way out. Hold on just a sec. Okay, so let's just double check our answer here. And it is at the point 2, 4. And I can see that in my graph as well. It looks like it crosses right there. It's just they're really close together, so it is kind of hard to see without using that point. That's part of the reason kind of why I picked this one for us to do together. Okay, so now my answer, according to this, is 2, 4. Okay, but keep in mind, those numbers have meaning, right? So remember, one of these is essentially an x-coordinate, and one of these is a y-coordinate. Well, for the x-coordinate, we said that was our variable e. So that means there are two people that are going to get the egg salad. And the 4 in the y-coordinate, that's going to be my c. So that is going to be my chicken salad people. Okay, and it also fits with what we said. More people wanted chicken salad. That fit with what we calculated. Okay, so that gives us a good indication that we're probably on the right track. Okay, so she can order 4 chicken salads and 2 egg salads. So that problem was pretty complicated, but realistically, the only thing that I think is really, really tough for a lot of students is this idea. Okay, this equation of just the two variables, when you add them together, give you the total number of people. Okay, and that's one you want to watch out for. This is a pretty common problem type. Excuse me. You will see stuff like this. Okay, so it's a good thing to get used to. All right, we're gonna do one more on this page. We're gonna do number 6. Okay. A softball team bought a box of sweatshirts for $240. Each sweatshirt costs $12 to print and will sell for $18. Graph a system of equations to find the number of sweatshirts the softball team needs to sell in order to break even. So the best way I know how to do this problem, in fact, there's really a few ways to do this one, but the way they want you to do it in the book is to do all the costs in one equation and all the profits, which is actually normally called the revenue. Okay, because the profit actually means something slightly different. The revenue is basically just how much money you make, okay? How much money you are given. Okay, so let's start with the costs. So let's read the question and see if we can figure out which ones go with the costs. What are we paying for? Okay, so a softball team bought a box of sweatshirts for $240. Each sweatshirt costs $12 to print and will sell for $18. Graph a system of equations to find the number of sweatshirts the softball team needs to sell in order to break even. Okay, so I know that there are 2 costs in this problem. Okay, so I'm going to do the costs in yellow. Okay, well, we bought a box of sweatshirts, so that means that's going to be part of our costs. Okay, and in addition, if we want to put a design on our sweatshirt, which we do because we're a cool softball team, each sweatshirt is going to cost $12. Okay, so that means we have to pay for the sweatshirts originally, and we also have to pay for each individual sweatshirt to get printed on. Okay, So let's use that to help set up our equation, okay? So the costs, let's just use, we'll use C, okay? The cost is equal to the number of sweatshirts. Actually, let's use P for price because that's what it uses over in our y-axis over there, okay? We know we're going to pay for the box of sweatshirts one time, okay? So in this case, that's going to be 240. Okay, you're not gonna have to buy the 240 every single time you buy a sweatshirt. You just bought the whole box of sweatshirts, and that's how you're calling it good. Okay, now the $12 to print, that's gonna be a cost per sweatshirt. So for every sweatshirt you buy, you're gonna pay $12. So if I buy one sweatshirt, $12. 2 sweatshirts, $24. Print 3 sweatshirts, that's $36. Okay, so you can probably figure out the pattern from there. We're gonna take our 12 and we're gonna multiply it times S, where S is the number of sweatshirts. That's going to basically function like our X variable in these problems. Okay. Now, one minor complaint, that equation is not perfectly in slope-intercept form just yet. So I'm going to take my equation and I'm just going to rearrange it, right? You can always take an equation and just move things around on the same side as long as you keep your signs the same. So notice how both of these numbers were positive. So both of my numbers in my second equation are also positive. Okay, so we've got our first graph. Then from there, we're going to go ahead and graph our revenue. Okay, revenue is the amount of money that we're going to make. So we're going to ignore everything we've highlighted in yellow. Okay, this time I'll switch to green. Okay, and basically you can probably figure out exactly what we're going to make because the only thing left is we're going to sell them for $18. So for every person who buys a sweatshirt, they're going to give us $18. We're going to make $18 back. Okay, so that means the price that we get back is going to be $18 times the number of sweatshirts, because for every sweatshirt we sell, we're going to make $18. So if I sell 10 sweatshirts, that's going to be 18 times 10, or in other words, $180. So this equation is also already in slope-intercept form. I don't need to go any farther because remember that this is basically my y equals mx, effectively. We're using s as my x coordinate just because it represents the number of sweatshirts, okay? And then plus b, well, there is no b value here. So that just means the b value is effectively 0. Now, normally we don't write that in, but if you want to kind of help you keep it straight, you're welcome to, okay? So now we go through and we actually graph these, okay? And again, we're going to kind of do our best here. So I'm going to start for my cost equation at 240. Okay, so I go to the y-axis. Looks like they're counting by 50s. 50, 100, 150, 250, or 200, 250. So 240 is going to be just a little below that. Okay, so I'm going to plot my first point there. Okay, so the next one, this one's going to be a little tougher, but it's counting by 5s. Okay, and my slope is 12. So that means normally I would go up 12 and over 1. Okay, 12 over 1, but the problem is I'm not counting by 1s here, okay? So don't try to count up 12 and over 1 because these boxes don't equal the same thing. My x-axis is counting by 5s, and my y-axis is counting by 50, so I need to be a little bit careful here, okay? If I move by 5, instead of going up 12 and over 1, I'm going to go up 60 and over 5. Okay, this can be a little bit tricky for a lot of students, but you can basically think about it like I'm going up 12 and over 1 5 times. Okay, so the way I would do that is I'd go up 12 5 times, which is 60, and I would go over 1 5 times, which is where the 5 comes from. Okay, and now it becomes a little bit easier to work because if I'm at 240 and I go up 60, well, now I'm at 300, and then I go over 5, so now I'm over here. Okay, from 300, I go up to about 360, which is going to be just a little bit above 350, and over 5, which again is basically one box over because we're counting by 5s here. Okay, and I can repeat that process. So now I'm at 360. When I add 60 to that, that's 420. So that's going to be somewhere right about right there. Okay, and then I'm at 480 when I'm at 20 here, which is going to be about right here. And you can already kind of see the line starting to form here. Okay. All right. So our next one, this one is just 18 as a slope. Okay, and we're going to do the same kind of thing we did with the 12. So I'm going to do 18 over 1, and again, I'm going to basically do it like I'm moving 5 times because they're counting by 5s on my x-axis. So 18 times 5, that is going to be 90, and 1 times 5, that is going to be 5. So for every time, I'm going up 90 and then over 5. Okay, and because my y-intercept is 0, I'm going to start my first point at the origin. And really that makes sense if you think about it, because again, that is effectively saying if you sell no sweatshirts, you're not going to make any money from the sale of your sweatshirts. Duh. Okay, so I'm going to move up 90 and over 5. Plot my first point. Okay, next one, now I'm at 90. I'm going to go up another 90. So 90 plus 90 is 180 and over 5. Okay, next one, 270 and over 5. 360, my favorite number, and over 5. Okay, next one is 450 and over 5, and so on. Okay, I probably should have switched colors again here. And man, again, they are picking really close numbers. That's another reason why I chose this one for us to do together. Okay, so again, this is going to be where Desmos is our best friend because we can use Desmos to kind of check ourselves off here. Okay, so we had our first equation as the price equaling, it was 240 plus 12S. Now, Desmos is really cool because Desmos does not care if your equation's in slope-intercept form. Desmos can graph just about anything. Okay, so we've got our point at 240 like we should, and continuing on in the same direction that we're used to. We also need to do price equals 18 times the number of sweatshirts. Okay, and again, remember, the answer on this problem will be where the two lines meet. Okay, so in this case, my answer looks like it's at the point 4720. Okay, so if I have the point 4720, so somewhere up here looks like where it meets. Okay, again, remember that those two things, those two numbers, mean different things. Okay, so remember that my x-coordinate here, or in this case, the 40, okay, that is the number of sweatshirts, and the 720 is the price. So at $720, my costs and my revenue are even. They are the same, okay? So that means that if I want to break even, I need to sell 40 sweatshirts. All right. That was another tough question, boys and girls, so hopefully you're not totally lost right now. Okay, last page we're going to talk about. This one is pretty simple. This is this is the reteach page. This is following basically the same stuff as before. Again, if they're in slope-intercept form, just graph them. If they're not, turn them into slope-intercept form, then graph them. Okay, and again, Desmos is your best friend. Use Desmos to kind of help you check as you do these. Okay, all right. The one last one that we are going to talk about. Okay, and that is this page. Solving systems of linear equations by graphing. So this one has you doing a few different things. So it says graph an example of two equations that have one solution, graph an example with no solution, graph an example with infinitely many solutions, and so on. Okay, this one is going to be almost the best place to go for this one is my other video that talks about the problem that says how many solutions, because I go through each one of these and show you examples of what they would look like. Okay. In addition, when you're answering these problems down below, it wants you to predict the numbers without graphing. Okay. But after you've made your prediction, check to see if you got it right. Don't just make a prediction and then not check it, because the whole point of this is for you guys to check and see how you're doing. Okay. All right. And then our last page, this one you should be able to figure out. This one is a pretty straightforward one. They kind of give you a lot of the situation here, but feel free to take a look. If you guys need help, please reach out to us. Okay. Alrighty.